This is G485 homework booklet, question number 29. Olber's paradox is based on two assumptions about the nature of the universe. State these two assumptions. The first assumption was that the universe is static or homogeneous. The mark scheme also allowed uniform density. Second assumption was that the universe is infinite. Next, we consider a graph showing the recessional speed of galaxies against the distance d from the Earth. Using this, we can find the Hubble constant. So, quite simply, we want to find the gradient of the graph. I've chosen this point here as it goes nicely through the grid on the graph paper, and we have 20,000 divided by 300 giving 67. Now that is 67 kilometers per second per megaparsec as the units are given here, and these match the axes on the graph. Now the next part of the question asks you to estimate the age of the universe in years. So that age is given by the reciprocal of the Hubble constant. However, we need to make sure that our units are appropriate. So looking back, we had 67 kilometers per second per megaparsec. We can convert the kilometers to meters by multiplying by 1000, and the per megaparsec we can consider to be on the bottom line of the fraction here, and converting mega we insert 10 to the power 6, and then we need the factor to convert parsecs to meters. This is given in the question here. We have 3.1 times 10 to the power 16 meters. So multiplying all this by 67 is placed here in the equation, and then the final factor here allows for the conversion from seconds to years. This leads us to an age of the universe of 1.5 times 10 to the power 10 years. Next, we're asked to calculate the critical density of the universe using the Hubble constant we have already found. So the Hubble constant that we are using is 2.1 times 10 to the minus 18 per second. This was found by the calculation here as above. We substitute that into the equation, 3 times the Hubble constant squared divided by 8 pi times the universal gravitational constant. That leads us to an answer of 7.9 times 10 to the minus 27 kilograms per metre cubed. We now move on to two remaining parts of the question that are descriptive. So first of all, describe how the fate of the universe depends on its average density. Now be careful here, the mark scheme gave no credit for the terms open, closed and flat. I suppose those would be naming three possible fates rather than describing them. So the first option is if the density is less than the critical density, then this would be too small to stop the expansion, and we would expect the universe to expand forever. An alternative option is if the density is greater than the critical density, then the universe would contract and would produce a big crunch. And the third option, close to or equal to the critical density, the universe expands towards a limit. You might say expands forever, but the rate of expansion tends to zero after infinite time. Last part of the question then, describing evidence for the hot Big Bang model of the universe. There are 4 marks attached to this part of the question, so you need 4 of the following 6 statements. So first option, the galaxies are moving apart or that the universe is observed to be expanding. Secondly, if the galaxies have always been moving apart, then at some stage they must have been closer together. Thirdly, you could refer to evidence in redshift. So you could say that blue light is shifted to red, or gamma radiation has shifted to microwave. Fourthly, the further away the galaxy, the faster the speed of recession. The fourth point refers to the existence of microwave background radiation. This radiation corresponds to an average temperature of the universe of 2.7 Kelvin. Do make sure you refer to microwave background radiation. Background on its own would not be enough. And finally, a comment referring to the fact that there is more helium in the universe than expected.